force and pressure. Introduction. All the living organisms except plants have the ability to move around. There are many other man-made things whose motion need to be initiated. Example, a football is a non-living thing that can't move on its own. We have to kick or throw it to initiate movement. A door cannot open or close until you push it. Kicking the ball or pushing the door needs some force. The effect of force on an object also depends on some factors. These factors are magnitude of force applied and the area over which the force is applied. Force. Force is defined as the strength or energy needed to attribute physical action or movement. When things are moved, changing their position, force plays a very important role. Some common applications of force in our everyday life are opening or closing of the door, lifting of your school bag or any kind of luggage, kicking a football, animals pulling a cart, tug-of-war between two teams. So, force is that pull or push which can change the state of motion or rest of an object. It can also change the shape, size, or dimensions of an object. The SI unit of force is Newton, denoted by N. The direction in which the body is pushed or pulled is called the direction of force. Effects of force. Force can bring about a number of changes. Some of the effects of force are given here. Force can change the state of motion. When force is applied on a body at rest, it begins to move. Example, a football kept on the ground starts moving on being kicked. Boxing bag starts oscillating on being punched. Force can change the speed of an object. A car slows down when brakes are applied and then gradually it comes to rest. A moving ball stops when stopped by the leg. A moving swing slows down its speed when somebody holds its rope. In all these examples, what we observe is that the speed of the moving object is being altered when force is applied. Force can change the direction of a moving body. When a bowler throws a ball, it moves in a forward direction. The same ball, when hit by the batsman, changes its direction. An automatic toy car, on hitting the wall, starts moving in some other direction. Thus, it is clear from the above given examples that force is capable of changing the direction of a moving body. Force can change the shape of an object. Force can change the shape of some objects or things, such as when an inflated balloon is pressed, clay is rolled on potter's wheel, and floor dough is rolled with a rolling pin. Types of force. When force acts on an object, it experiences a push or pull. Thus, there is a necessary interaction between the objects for the force to act. The moment this interaction ceases, the force also ceases. This interaction between the objects may be due to contact force, non-contact force. Contact force. When force acts between two objects or when they are in physical contact with each other, the force is said to be contact force. Example, when a footballer kicks the ball with his leg, the ball and the leg are in connect with each other. Thus, it is contact force. Contact force may further be classified into muscular force, frictional force, mechanical force. Muscular force. The force applied by our muscles in doing any activity is termed as muscular force. Pushing the door, lifting up a heavy box, opening the table drawer, all require muscular force. Animals also make use of muscular force to carry out their physical activities. The animals like bullocks, oxen, horses, donkeys, and camels are used to do different tasks for us. They also use muscular force for all these activities. Frictional force. Force of friction acts on the moving objects. When an object slides or rolls on a surface, a force termed as frictional force comes into play between the surface in contact. It tries to stop the object from moving. Friction is also generated by rubbing hands. Mechanical force. In some cases, machines are used to generate force. The force so generated is called mechanical force. In simple terms, mechanical force is the force generated by machines. Some examples are forces generated by a screwdriver, stapler, or rail engine. Non-contact force. This type of force arises when objects are not in physical contact with each other. The force that acts on the objects from a distance is termed as non-contact force. Some non-contact forces are gravitational force, magnetic force, electrostatic force. Gravitational force. The force exerted by the earth on all objects is called gravitational force. It is due to this force that everything is attracted towards the earth. This force is an example of non-contact force, as all objects are not necessarily in contact with the earth. The gravitational force exerted by the earth opposes the upward moment of an object. Due to this pull, the speed of the object decreases and the object finally falls down. The gravitational force is also termed as force of gravity or just gravity. Weight is a measure of the gravitational force exerted by the earth. Magnetic force. Magnetic force refers to the force exerted by a magnet on a magnetic substance. This force acts on an object from a distance. The examples of magnetic substances are iron, steel, nickel, and cobalt. Magnetic force finds its application in a number of areas, like separating scrap iron from a heap of garbage. Electrostatic force. After combing your hair, when you bring the comb close to the bits of the paper, they are attracted towards it. This force is an example of non-contact force termed as electrostatic force. Spring balance. Spring balance is a device that measures force. It uses the principle that greater the force, the greater is the extension that force produces on a coiled spring. It consists of a coiled spring with a pointer attached to it. As the spring is stretched, the pointer moves on the graduated scale. The reading on the scale gives the magnitude of the force. When we move on sand, our feet sink into it and it is difficult for us to walk. On the other hand, a camel who is much heavier than us can walk on sand easily. This is because a camel has broad feet. It is easy to cut fruit and vegetables with a sharp knife than with a blunt one. This happens because a blunt knife has a larger area of contact. From these examples, we can conclude that the effect of force depends upon the area of contact of the two objects. Lesser the area of contact, more is the effect of force, and vice versa. That is why it is easy to push a sharpened pencil into an eraser, as the area over which the force is applied is small. That increases the effect of force on the pencil. Thus, pressure is a measure of the effectiveness of force. It takes into account the force and the area over which it acts. Pressure can also be defined as the force acting on per unit area of an object. Pressure is equal to force upon area. Therefore, unit is equal to Newton upon meter into meter is equal to N upon m square. The unit of pressure is N upon m square in SI system. This unit is also called Pascal, PA, after the French scientist Blaise Pascal. Practical unit of pressure is bar, which is equal to 1 lakh Pascal. Applications of pressure. Pressure finds its various applications in everyday life. Nails and needles have a pointed tip to decrease the area of contact so that for a given force, the pressure exerted is more. Buses and trucks have double wheels at their rear to increase the area of contact so that the pressure exerted on the ground is less. High and tall buildings have broad foundations so that their pressure is less so as to prevent them from sinking. Heavy animals like elephants have broad feet to decrease the pressure exerted by them on the ground while they walk. Army tanks have caterpillar wheels to increase the area and thereby exert less pressure on the ground in the battlefields. Pressure exerted by liquids. Pressure is exerted by liquids also. The pressure at the bottom of the sea is very high. It is for this reason that deep sea divers wear a special suit to prevent their bodies from getting crushed. Liquid pressure is measured using a manometer. Atmospheric pressure. Just like liquids and solids, gases also exert pressure. The blanket of air around us is called atmosphere, and pressure exerted by it is called atmospheric pressure. The atmospheric pressure is about 10 raised to 5 N divided by m square at sea level and is called normal pressure or standard pressure. We do not feel this pressure under normal conditions, as this pressure is counterbalanced by the pressure of the blood running in our blood vessels. This pressure is called blood pressure. On higher altitude, the atmospheric pressure decreases. However, the blood pressure remains the same. It is for this reason that our blood may start flowing out through the nose and the problem of nose bleeding starts. Fountain pens also start leaking at higher altitudes. A pressed rubber does not come off because of this only. Atmospheric pressure is measured using a barometer.